Good evening, pre-algebra students. This is your flipped lesson for December 2nd, 3rd, and 4th. It won't be a particularly hard lesson, I don't think. Today we are going to solve inequalities. Inequalities. What's an inequality? That's when you have a less than, a greater than, a less than or equal to, or a greater than or equal to. It means that they don't have to be exactly equal. That's why we call them inequalities. Now, by the way, I know some of you get less than confused with greater than. Do me a favor, hold up your left hand in front of your face and put your index finger up and your thumb out. You're making an L, right? Make an L. What hand are you using? You're using your left hand. The left hand makes an L for less than. Less than is on your left hand. You'll never get that wrong again. So during a test or a homework, if you're not sure which one's which, I expect to see you hold that left hand up, make an L, and then you'll see the less than is on your left hand. And then the other one must be the greater. Greater than. And I guess it might be a little confusing. Yikes, that's a little lag there. I'll put the less than or equal to over here. These are the less thans, those are the greater thans. All right, good deal. Now, the cool thing is about solving an inequality. Like say we have a situation like this, where we have 3x plus 4 is less than, oh, what do I want it to be less than? How about 13? All right, I'm going to pretend it's just like an equality. I'm going to do it the same exact way. I'm going to use my Saddam questions. Yeah, I'm not going to forget about good old Saddam, my buddy Saddam. Yes. Subtract, undo subtraction and addition before undo multiplication and division. That's what Saddam tells me to do. The best advice Saddam ever gave, probably. All right. I know that x is not alone. There's a 3 attached by multiplication, a 4 by addition. I will undo the addition first because Saddam told me so, and I will subtract 4 from each side. All right, 3x is less than 9. Is x alone? Why, no, it's not. So I must undo that multiplication. How do I undo multiplication? I'll divide. Yeah, and therefore x is less than 3. Now, a really cool thing about this is I can put this on a number line. Yeah, because there are a lot of numbers that make this true. Wouldn't you agree that 1 is less than 3? 2 is less than 3. 1.5 is less than 3. 0 is less than 3. -5 is less than 3. I'll bet Kareem is thinking right now, geez, there's an infinite number of possibilities. Because no matter what number you name less than 3, we can always name 10 more. -20, negative a Google, -76, negative the square root of 3. Exactly. They just keep going on and on. So to show our solution, we make a number line. And on our number line, we have to show this number right here. We have to show the 3. It's very important. If you'd like to show a couple other numbers, you go right ahead. You could show, say, 0, maybe 6. Show a number on each side of the number line. That's fine. I'm going to put an open circle here at the 3. Why am I going to put an open circle? Because this was only a less than. Only a less than. If I had said the word equals, I would color that circle in. I didn't say the word equals, so I'm not going to put it in. And now I'm going to shade in the direction that gets me a true statement. For example, is 6 less than 3? Is 6 less than 3? I won't shade towards the 6. But is 0 less than 3? Ding, 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 ding. It is. I will shade towards the 0. Hold on, let me get my cool shader. This is such a cool shader. All right. And that needs an arrowhead on it because it goes forever. So that's, I solve it, but then I put it on a number line. Let's check out another one here. Another one. We'll do an equals to this time. How about if we had the problem 2x plus 4 is greater than or equal to, I don't know, 10. Again, I pretend it's just like an equation. I'll subtract 4 from each side. I think I subtracted 4 in the last one. I must be stuck on that number. Probably because I'm tired. It's been a long week. Pardon my editorializing. All right. There we go. 2x is greater than or equal to 6. Now, x is not alone. It's attached to a 2 by multiplication. I'll divide by 2 on each side, and I will get the solution that x is greater than or equal to 3. It looks like the same solution. It's not, because now I need the numbers that are greater than or equal to 3. For example, is 3 greater than or equal to 3? Yeah, 3 is greater than or equal to 3. That is a true statement. But there's lots of other numbers. 3.5 would be greater than or equal to 3. 1,000 would be greater than or equal to 3. A Google, etc., etc. So there's going to be actually a different solution. Let's get a number line down here. Whoop. Again, 3 is the important number. It won't always be. It just happens to be the way this problem worked out, probably because I made it up off the top of my head. I'll make up a different one for the next example, and it won't be 3, something else. All right, I put the 3 on. I said it was going to be a closed circle because of this equal sign, greater than or equal to. All right, now, if you want, you can put a couple numbers over here, one on each side of it. These numbers here all make it true. I have to make sure they're included in my shaded region. A number that would make it false might be, say, 0 is less, oh, excuse me, my mistake, it's greater than or equal to. 0 is greater than or equal to 3. That is not a true statement. Oh, this is fun. So, I won't shade in the direction of 0. I will shade in the direction of the numbers that do make it true. Ooh, get my spray paint out. Ooh, look at that. Oh no, Mr. Morgan's going to be upset. I just spray painted on the board. Oh my goodness. Okay, so let's look at another example. Now this one's a very special case. Something very special is going to happen in this case. Let's take negative 5x plus 7, and we will make that less than or equal to, what would be a good number? Let's go with negative 23. Yeah, that's the ticket. All right, again, I'm just going to solve it like a normal equation. I'm going to subtract 7 from each side. Okay, and then I'm going to get negative 5x is less than or equal to negative 30. Negative 5x, the x is not alone. I'm going to have to divide by a negative 5, right? Whoop, 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 whoop. Warning, warning, warning. When you divide or multiply by a negative, 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 did I mention that we were going to divide by a negative in this problem? When you do that, your inequality must change direction. This will cancel, leaving just an x. This will be negative 30 divided by 5 is 6. But this will no longer be a less than or equal to. It'll be a greater than or equal to. Yeah, when you multiply or divide by a negative on both sides, the inequality will change direction. It will flip. You heard all the warning bells. Again, I can put it on a number line. Right? I'll put 6 on this time. It will need a closed circle because it's equal to. I'll show some numbers over here. And I want numbers that make this true. Notice I don't have any little rules about shade the way the arrow points. Don't do that. Pick a number that makes it true. Does 0 make this true? Or does 10 make it true? Is 0 greater than or equal to 6? Thank you for playing. We have some lovely turtle wax for you. Is 10 greater than or equal to 6? Absolutely. We will shade in the direction of the 10. Mr. Morgan yelled at me, so I couldn't use my spray paint feature on that one. Actually, I just forgot to. All right, we're going to get some practice with this on Monday in class. I'm very proud of you. 8th period, I couldn't believe how class went 8th period. You guys look like one of my algebra classes where you're working with your partners, you're collaborating, you're talking about problems, you're going up and checking answers, you're coming back, you're discussing what's wrong. I was able to float around and help the people that were really having trouble. Keep it up, guys. You're doing great work. I am so proud of you. All right, please watch this video more than once. It will help you in the long run. All right, Mr. Lawrence signing off.